Hello Gen Zs, welcome to the channel HALOGEN-Z. Students, आज हम पढ़ेंगे चैप्टर 2 Acids, Bases and Salts. Let us directly move to the class. Students, आज हम शुरू करते हैं चैप्टर नंबर 2 Acids, Bases and Salts. Students, जैसा कि आप सब जानते हैं, हर एक क्लास में 3 प्रकार के स्टूडेंट्स होते हैं. एक वो जो बहुत सिंसियरली पढ़ते हैं, क्लास में कभी टीचर को डिस्टर्ब नहीं करते. दे एक्ट एज न्यूट्रल. उनका क्लास में होना या ना होना ऐसे लगता है मानो क्लास खाली है, क्योंकि वो कभी टीचर को किसी भी कंडीशन में परेशान नहीं करते. सिमिलरली कुछ ऐसे प्रकार के स्टूडेंट्स जो स्वभाव से बहुत अच्छे हैं, टीचर को रिस्पेक्ट बहुत करते हैं, लेकिन उनके पीछे जाते ही शरारतें शुरू कर देते हैं. एक वो प्रकार के बच्चे जो नेचर से यानी हमेशा सदैव कड़वा बोलते हैं, दूसरों के साथ एरोगेंस शो करते हैं. उसी प्रकार कंपाउंड्स भी 3 प्रकार के होते हैं ऑन द बेसिस ऑफ केमिकल प्रॉपर्टीज. फर्स्ट वन इज एसिड्स. एसिड्स आर sour in taste, like those students those who are notorious, they disturb the teachers but they always remains polite. Now the second one, those who are bitter in taste, the bases are bitter in taste, and the third one is neutral like salts. So we can say on the basis of chemical properties, compounds are of 3 types. One is acids, the second one is base, and the third one is salt. तो सबसे पहले शुरू करते हैं acids. Students, acid वो substances हैं जिन्हें पानी में डालें तो H+ ions देते हैं. ये H+ ion जो रिलीज करते हैं एसिड, वो पानी के मॉलिक्यूल से कंबाइन करते हैं और हाइड्रोनियम आयन बनाते हैं. तो एक बार फिर से डेफिनेशन देखते हैं एसिड की. जो सब्सटेंसेस पानी में डिसॉल्व होने पर H+ आयंस देते हैं, उन्हें हम एसिड के नाम से जानते हैं. दे आर ऑलवेज sour in taste, यानी वो स्वाद में खट्टे होते हैं. इमली स्वाद में खट्टी है, दैट मीन्स इट कंटेन एसिड. नींबू स्वाद में खट्टा है, दैट मीन्स इट कंटेन एसिड. यदि दही खाएं, उसमें खट्टापन है, दैट इज ड्यू टू लैक्टिक एसिड. नींबू ऑरेंज का खट्टापन सिट्रिक एसिड की वजह से, और इमली का खट्टा होना टार्ट्रिक एसिड की वजह से. सो दीज आर वेरियस एग्जांपल्स ऑफ ऑर्गेनिक एसिड्स. बट अदर एग्जांपल्स ऑफ एसिड्स आर hydrochloric acid. The second is sulfuric acid, which is called king of chemicals, because the country's economy, or you can say the strength of a country or development of a country, can be known by the production and use of sulfuric acid. So sulfuric acid is called king of chemicals. Third one is nitric acid. It acts as strong oxidizing agent. Other acids are also there: perchloric acid, peroxodisulfuric acid, etc. Now students, acids are of 2 types. One is called strong acid and the other one is called weak acid. Now what are strong acids, students? Those substances which dissolve in water and give 100% H+ ions are called strong acids. Mineral acid act as strong acids. Example are hydrochloric acid, sulfuric acid, nitric acid, etc. Whereas weak acids are those substances which dissolve in water but give less number of H+ ions. Example are acetic acid, which is present in vinegar, maybe oxalic acid present in tomato, or citric acid present in orange or lemon. So these are weak acid which give less number of H+ ion, and strong acid which give 100% H+ ions. Now let us come to bases. Students, bases are those substances which dissolve in water and give OH- ion, that is hydroxide ions. So bases, they always give hydroxide ion when dissolved in water. Now these bases are also of 2 types. Those bases which are soluble in water, we call them by a name called alkali. So simply we say alkali is a substance which dissolve in water, but they are mainly bases. The soluble bases are called an alkali. Example are sodium hydroxide. The second one is potassium hydroxide. They dissolve in water and they act as strong bases. So we can say bases like acids are also of 2 types. One is strong base and the other one is weak base. Strong bases dissolve in water and give 100% OH minus ions. Similarly, weak bases, they dissolve in water but do not give 100% OH minus ions. That means when bases are put in water, weak bases, then actually what happens, they do not dissociate completely. So an equilibrium is achieved between the ions and the undissociated base. Similar is the case for weak acid as well. That means in weak acid and weak bases जो 100% dissociate नहीं होते, तो actually molecule यानी undissociated molecule और ions बनने के बीच में एक equilibrium आ जाता है. यानी हमको solution में acid भी मिलेगा weak acid में और उससे given ions भी मिलेंगे. उसी प्रकार weak base के अंदर molecule भी मिलेगा weak base का और साथ में suppose if I take ammonium hydroxide, ये एक weak base है. यदि मैं इसे पानी में ऐड करूं तो ये अमोनियम हाइड्रोक्साइड पानी में डिसॉल्व होकर हाइड्रोक्साइड आयन और अमोनियम आयन बनाएगा, लेकिन 100% OH माइनस नहीं देगा. इसका मतलब मे बी पॉसिबल 40% डिसोसिएट होता है तो क्या होगा, 60% अमोनियम हाइड्रोक्साइड होगा और 40% और 40% हाइड्रोक्साइड और अमोनियम आयंस होंगे. दैट मींस इक्विलिब्रियम इज अचीव्ड. लेफ्ट हैंड साइड वाले भी मिलेंगे, राइट हैंड साइड वाले मिलेंगे, जिसे हम कहते हैं इक्विलिब्रियम इज अचीव्ड व्हेन वीक एसिड एंड अ वीक बेस इज डिसॉल्व्ड इन वाटर. तो स्टूडेंट्स, एसिड और बेस के बाद जो तीसरा सब्सटेंस है वो है सॉल्ट्स. Acid react with the base to form salt and water and the reaction is called neutralization reaction. Example देख लेते हैं. Hydrochloric acid when treated with NaOH, it formed NaCl and H2O. So NaCl is a salt and you know salt is soluble in water. Now if you want to know the nature of an acid or a base, that means if you want to know whether a substance possess or a solution possess an acid or base in it, then a chemical is used, whether it is man-made or found in nature. And the substance that help in founding the nature of acidic or basic nature, they are called indicators. So let us see the definition of acid-base indicators. Those substances which indicate the acidic or basic nature of a solution, we call them by name acid-base indicator और simply कहते हैं उन्हें indicators. Students, ये indicators दो प्रकार के होते हैं. एक कहलाता है natural indicators, वो indicators या वो substances जो nature में मिलते हैं. पहला नाम litmus, the number 2 turmeric, number 3 that is red cabbage leaves, और fourth है petals of some flowers, colored flowers, maybe hydrangea, petunia, geranium. Similarly, we see the other type of indicators. Their names are, one is methyl orange and phenolphthalein, but these are man-made. So we can say the first variety of indicator is natural indicator, the substances found in nature and we are using that as an indicator to find out the acidic or basic nature of a solution. जैसे example बताए, litmus, turmeric, red cabbage leaves and colors of flowers like hydrangea, petunia, geranium. इधर देखते हैं man-made indicators को कहते हैं synthetic indicator. उसके दो बहुत famous नेम हैं, एक को कहते हैं phenolphthalein और दूसरे का नाम methyl orange. Now let us see, begin with the first name that we have said कि पहला इंडिकेटर जिसका मैंने नाम लिया उसका नाम था लिटमस. स्टूडेंट्स, लिटमस एक पर्पल कलर डाई है जो हम एक्सट्रैक्ट करते हैं लिचन से. इसे हम LICHEN, जिसे हम लिचन भी कह सकते हैं और लाइकन्स भी कह सकते हैं. डिफरेंस इतना सा है कि एक ब्रिटिश एक्सेंट है और दूसरा अमेरिकन एक्सेंट. तो वेदर यू से लिचन और लाइकन्स बोथ आर करेक्ट. So litmus is a purple colored dye which is neutral in nature, that is neither acidic nor basic in nature. So it is neutral in nature, purple in color, and obtained or extracted from lichen or lichens which belongs to a division called Thallophyta. This lichen is neither a plant or nor an animal. Then the question arises what it is. It is actually a combination or symbiotic association between an algae and a fungus. Students, lichens are found everywhere from desert to the Arctic. Help in cleaning the air and they are used as biomonitors. That means they tell us the health of the surrounding air. Students, now the question arises, though the litmus solution is purple color, but we say the litmus dye is of two types. One is blue litmus and the other one is red litmus. So how do it happens? ये कैसे पॉसिबल है कि एक पर्पल कलर की डाई एक ब्लू कलर लिटमस है और दूसरा रेड कलर? Actually what happens, if some amount of acid is added to that purple color, it turns red. That means if purple color solution extract is there of litmus and if acid is added to it, it turns red and we call it as a red litmus solution. And if a base is added to the purple dye, then we call it as blue litmus solution. So we can say litmus solution is of two types. One is called blue litmus and the other one is called red litmus. Students, acid turn blue litmus red. Now the question arises, if acid turn blue litmus red, if red is added to it, what happens? Red remains red, or we can say there is no change in color. Similarly, if red litmus is there and if it is added to any base, then bases turn red litmus blue. Then if blue litmus is added to a base, what happens? Blue remains blue. That means there is no change in color. So students, we can say in short, acids are those substances in which blue litmus turns red and bases are those which turns red litmus blue. Students, आजकल litmus solution के साथ साथ blue litmus paper and red litmus paper भी आता है जो उसी प्रकार वर्क करता है जैसे litmus solution वर्क करता है. litmus solution के बाद next natural indicator है हल्दी. Yellow stain of a curry turns reddish in basic solution. कपड़े में हल्दी के लगे हुए दाग पीले दिखाई देते हैं. जब उस पर साबुन अप्लाई किया जाता है तो रेडिश दिखाई देता है. रीजन है सोप सॉल्यूशन इज बेसिक इन नेचर और जब उस पर पानी डाला जाए और सारा साबुन हट जाए तो वो दाग दोबारा से पीला दिखाई देता है. सो टर्मरिक इज अ नेचुरल इंडिकेटर. इसके बाद नेक्स्ट है रेड कैबेज लीव्स. एक्सट्रैक्ट ऑफ रेड कैबेज लीव्स इज रेड इन कलर which turns green in basic solution. Next is hydrangea. Flowers of hydrangea are blue in color and turns pink in basic solution. After natural indicators, the next variety is synthetic indicators, that is man-made indicators or artificial indicators. The two famous names are, one is phenolphthalein, other one is methyl orange. Phenolphthalein is acidic in nature, so it gives color pink in a base. Once again, phenolphthalein is a colorless solution which remains colorless in an acid, that is no change in color, but it turns pink in a base. Next is methyl orange. It is yellow in color, so it gives red color in an acid and in a base it remains yellow. How to remember whether phenolphthalein or a methyl orange will give color in an acid or a base? The best trick is, remember the phenolphthalein word starts with P. So if I write H in front of P, it becomes HP. You can say Hindustan Petroleum, Himachal Pradesh. So it can HP. If H comes in front, it seems as if it is an acid. Like HCl, H2SO4, all these compounds possess hydrogen in front. So it gives appearance as phenolphthalein is acidic in nature. So acid will not give color in an acid. It will definitely give color in a base. So phenolphthalein remains colorless in an acid but gives color in a base, and that color is pink. So P for phenolphthalein and P for pink. So phenolphthalein always give pink color in a base. Next is methyl orange. Methyl starts with M, orange with O. So if I write M and O and write H at last, it becomes MOH and it seems as if जैसे ये base है because OH दिखाई देता है. तो यदि ये बेसिक नेचर है तो ये कलर देगा एसिड में. तो मिथाइल ऑरेंज टर्न्स रेड इन एन एसिड बट रिमेन्स येलो इन अ बेस. सो दिस इज सिंथेटिक इंडिकेटर्स. स्टूडेंट, after this indicators there is one more variety of indicators. They are called by a name olfactory indicators. Olfactory indicators are those indicators whose smell changes in acidic and basic solution are called those olfactory indicators. Once again, olfactory indicators are those substances which show the acidic or basic nature of a solution by showing a change in smell. So these are two variety. One type of indicator, acid-base indicator, they show the acidic and basic nature by showing a change in color. But olfactory indicators, they show a change in smell, and then with the help of it, we identify whether a solution is acidic or basic. So examples of olfactory indicators are: number 1, clove oil; number 2, vanilla essence; third one is onion juice. So students, if onion is taken, take some chopped onions, put it in a polythene bag and put a small cloth in it and put it in a fridge for some hours. You get, after some time, when you take out that polythene and take out that cloth, cut it into few pieces, and one of the strip or a piece put some amount of acid, and the other one you add a base. What we see when acid is put on that onion strips, we see the smell of the onion do not get destroyed. But if a base is added, for example sodium hydroxide is put onto it, then the smell of that onion disappears. Similarly, we know that vanilla essence has a characteristic pleasant smell. So whenever an acid is added to it, what happens? The smell of that essence do not get destroyed. But if a base is added to it, the smell of vanilla essence gets destroyed. Students, thank you for watching the video. Do like, share and subscribe the channel, and do not forget to press the bell icon so that you can receive the notification of the new videos. Thank you.